Hello friends, I am Dr. M. Fatima from Saga Institute of Research and Technology. Today I am taking static characteristics of instruments. The static characteristics are those characteristics of an instrument which does not change with respect to time, that is constant or static with respect to time. There are different static characteristics of an instrument. They are range and full scale, accuracy or tolerance, precision or repeatability or reproducibility, linearity, sensitivity of measurement, sensitivity to disturbance, hysteresis effects, dead space or threshold, and resolution. Accuracy of an instrument is a measure of how close the output reading of the instrument towards the correct value, or we can say how close the measured value towards the true value. In practice, generally, the accuracy is written in terms of inaccuracy figure rather than the accuracy figure. So inaccuracy is the extent to which a reading might be wrong and is often quoted as a percentage of full scale reading or true value of an instrument, which is written here. The inaccuracy or error is equal to the part of the maximum error divided by full scale reading and can be multiplied by 100 for percentage. Now, this inaccuracy or error can be written as measured value minus true value divided by true value. That is, the inaccuracy is written in terms of true value. And measured value minus true value divided by full scale reading. That is, the inaccuracy or error is written in terms of full scale reading. The measured value minus true value is giving the error. Let's take an example. Here, this is a thermometer which gives an actual temperature of 23 degrees centigrade, and this thermometer reads a value of 25 degrees centigrade. So this is the measured value and this is the actual value or true value. Now put this measured value and true value in this formula. 25 minus 23 divided by 23 multiplied by 100. So this is giving 8.7% error or inaccuracy. So this thermometer reads with an error of 8.7%. So this is required that the instrument must have low errors. Now next is precision. Precision is the degree of repeatability or how reliably it can reproduce the same measured value over and over. Or we can say how reliably it can repeat the series of values, series of measured value over and over. Let's take an example. Here, the arrows are targeted to hit at the yellow area or at the yellow center. So these cross signs are showing the arrows are hit on these areas. So here we can say the arrows are somehow nearby to the center target value. So these values are the accurate values. But if we talk in terms of instrument, if the instrument gives these values which are near to the true value, then this instrument is called accurate instrument. If we see this picture, in this picture, the arrows hit it very nearby to each other, but somehow far away from the target value. So these readings are called precise readings. But if we talk in terms of instrument, if the instrument gives the readings or the measured value which are very nearby to each other and far away from the true value, such an instrument is called precise instrument. Now see in this picture here, the arrows are hit at the center and very nearby to each other. So these results are called accurate and precise. And if we talk in terms of instrument, if the instrument gives the values which are very nearby to each other again and again, and if it is near to the true value, then this instrument is accurate as well as precise. Now, see this picture here, the arrows are hit at random places. And if we talk in terms of instrument, if the instrument gives random values, again and again, different values are giving, and which are very far away from the true value, then this instrument neither be accurate nor precise. So this completes this lecture. Thank you, friends.